morning to all. I'm here to host today's event, International Webinar on Chemical Science for Sustainability. A warm welcome to one and all present here. It gives me an immense pleasure to welcome you all to the webinar organized by Department of Chemistry.
Prayer is a window to opportunity, a door to miracles, a channel for blessing, and a path to dreams comes true. Now, I invite our department singing birds to invoke the presence of God amidst us through a prayer song. Come, Holy Spirit, source of life, our eyes open and give us sight. Come, Holy Spirit, fire of life, set our minds on things that are above. Come, Holy Spirit, Spirit of God. Come, Holy Spirit, Spirit of the Lord. We adore you, we glorify you, with sincere heart, loving and true. We adore you, we glorify you, with sincere heart, loving and true. Come, Holy Spirit, source of life, when you will help in Jesus Christ. Come, Holy Spirit, source of strength, help us keep our faith unto the end. Come, Holy Spirit, Spirit of God. Come, Holy Spirit, Spirit of the Lord. We adore you, we glorify you, with sincere heart, loving and true. We adore you, we glorify you, with sincere heart, loving and true.
Thank you all. Now I invite the students to read out the Holy Book.
A reading from the book of Colossians, chapter 3, verse 17. Whatever you do in word or deed, do everything in the name of the Lord Jesus, giving thanks to God the Father through him. The word of the Lord, thanks be to God.
Reading from Bhagavad Gita. A gift is pure when it is given from the heart to the right person at the right time and at the right place, and when we expect nothing in return.
About me. Indeed, I am sure. I recent call upon me. So let them also respond to me and believe in me, so they may be guided.
Thank you all. May I now invite Dr. S. Shekhar, Assistant Professor, Department of Chemistry, to address the gathering. Welcome you, sir.
A pleasant morning to one and all gathered here. At the outset, I take the deepest blessing of Almighty to cherish the day with victory and glory. As it is rightly said, research is creating new knowledge. Today, the ultimate aim of this noble gathering is to provide knowledge among the thirsty minds. I welcome you all wholeheartedly. Primarily, I am in depth to welcome our college secretary, Reverend Mother C. Noel Rani, FSAG, on this occasion, who is in all the walks of our college towards success. Behind every successful woman is a tribe of other successful women who have her back. Yes, our most respected principal, Reverend E. Lita Sumangali, FSAG, is a powerful house of our love, nobility, and willpower. With due respect, I take the honor of welcoming her. I welcome you, sister. We rise by lifting others. our Vice Principal Reverend Sister A. John Diana, FSAG, keeps this motto as her life motto. And I now take the pleasure of welcoming her. I welcome you, Sister. An electrochemist is one who always relates electron behavior by means of voltage in explaining the chemical and physical reaction between the charged particles. The way goes the way and shows the way. Our today's resource person, Dr. Isaki Karthik, research scientist, Research Institute for Sustainable Energy, Kolkata, is a great dynamic personality who serves service in research in development of fundamental electrochemistry to technology transfer. I welcome you wholeheartedly to this victorious gathering, sir. And I'm honored to extend my warm welcome to Dr. R. Karthik, Research Professor, South China Normal University. It's a great pride to our country who serves his service in China. A good friend of mine and kind-hearted person, I welcome you happily to this noble gathering, sir. Then I am extremely indebted to welcome the coordinator, Ms. C. Anjali, Assistant Professor and Head of the Department of Chemistry. I welcome you, ma'am. Then I am pleased to welcome the Organizing Secretary, Ms. M. Sweta. Welcome you, ma'am. I am happy to welcome Dr. R. Dinesh Kumar, Assistant Professor, Department of Physics, who is here with us and consented to deliver valedictory address. Welcome you, sir. Then I take the great privilege of welcoming you all to this event and staff members and committee to this webinar. Welcome you all. I'm extremely overwhelmed to see a massive participants around the globe. I welcome you all, dear scholars, scientists, subject experts, professors, students from various colleges and our colleges, media personnel, and each and everyone gathered here. Once again, a cordial welcome to all. We welcome you, sir.
Thank you, sir. Now, I invite our Honorable Principal, Reverend Dr. E. Glita Sumangali, FSAG, to deliver the Presidential Address. We welcome you, Sister.
Thank you very much. Respected resource persons of today's international webinar, Dr. Esaki Karthik, research scientist, RISE Calcutta, India, Dr. R. Karthik, research professor, South China Normal University, China, Ms. C. Anjali, head of the Department of Chemistry, Dr. S. Shekhar, convener of this international webinar, Ms. M. Sweta, organizing secretary, staff coordinators of the department, research scholars, participants from our college and from various other institutions. Greetings to all of you. It is with immense pleasure I appreciate the head of the department, convener, organizing secretary, and coordinators for taking unswavering effort to invite resource persons from reputed institutions and organizing international webinar on a very novel and interesting title. Chemical Science for Sustainability. I congratulate the organizing team for their indomitable contribution that you make for the progress of the department, growth of the students, and society at large. Props to you for your dedicated service to the nation as well. In Bible, it is written in the book of Genesis that God created the nature. God saw everything that he had made, and behold, it was very good. He blessed them, and God said unto them, be fruitful and multiply and replenish the earth and subdue it and have dominion over every living thing that move upon the earth. He continued, behold, I have given you everything, and you take care. So God has entrusted us the responsibility to use the resources and to sustain the nature of the creation. Yes, the use of natural resources and right balance of the same are at the hand of human being, especially at the hand of researchers and scientists. All matters is composed of 5 basic elements. You are well aware of it, which inhere the properties of earth, water, fire, wind, and space. These five elements are very essential for our survival. It is also blessings. To make the best use of it is our effort. Similarly, chemicals are key components of materials used in wind turbines, solar panels, electric batteries, and building insulation in addition to playing a vital role in every needs of society from medicine to clothes. We have abundance of natural resources, but still struggle out of deficiency. Hope we need to involve in research and to evolve solution to the problem. We have oceans surrounded by the earth, but we face water scarcity. We have wind and water energy. Still, we face power shutdown and cuts. It is right time and forum to reflect and identify a strategy. We believe the strategy should be based on key pillars: enforcement, implementation, and innovation. I am certain this knowledge sharing will instill students with research skill. I am also aware that sustainable chemistry seeks to improve the efficiency with which natural resources are used to meet human needs for chemical products and services. It encompasses the design, manufacture, and use of efficient, effective, and safe and more environmentally benign chemical products and processes. It is also a process that stimulates innovation across all sectors to design and discover new chemicals, production processes, and product stewardship practices that will provide increased performance and increased value while meeting the goals of protecting and enhancing human health and environment. So, I hope and pray that this seminar will pave a platform to all the participants who are taking effective participation, will identify the problems of today, and in an innovative and novel way, you will come out with solution after having a discussion and knowledge sharing by the resource persons. Once again, I extend a cordial welcome to all the participants on behalf of the Secretary, Vice Principal, both teaching and non-teaching staff, and student of our college. I wish a warm welcome and prayers to have a very productive discussion. All the best. May God be with you all. Thank you for the opportunity.
Thank you, sister. May I now invite Ms. L.M. Manimehalai, Assistant Professor, Department of Chemistry, to give introduction about our resource person.
We are delighted to have you among us. You are going to be a valuable asset to our department, and we can't wait to see all that you accomplish. Most people think of success in terms of getting success. However, begins in the terms of giving. So now I invite the resource person, Dr. Isaki Karthik. He has completed his BSc and MSc in chemistry from Manonmaniyam Sundaranar University, Tamil Nadu. He has qualified CSIR UGC JRF examination, and he joined PhD followed by completing a doctorate from CSIR Secretary Karaikudi. Under the guidance of Dr. K.L.N. Pani, during this doctorate program, he completed an Indo-Australian Monash University joint project for developing a water oxidation catalyst to generate a hydrogen. His main interest was surface electrochemistry and electrified interface. Later, he moved to ISER Mohali, where he mainly worked in the area of waste to wealth generation for utilizing a waste polybags for useful applications, and got a project from DST, the Indian government, for developing a stable water oxidation catalyst. Then he was invited as a visiting professor to the University of Brescia, Italy. Afterwards, he joined in ISER Thiruvananthapuram as a postdoctoral researcher for developing oxygen-based redox catalyst and electrochemistry of metal clusters. Next, he moved to the Hanyang University, Seoul, under Brain Korea 21 program, where he worked in electrochemical hydrogen generation and utilization of electronic waste. In August 2022, he joined as a research scientist, Research Institute of Sustainable Energy under TCG Crest. Now, his interest is to achieve a sustainable society through developing a fuel cell technology for energy storage, carbon dioxide reduction for controlling a green gas emissions, water electrolysis for hydrogen fuel generation, and electronic waste utilization for pollution free society. He has secured many awards in his career. Secured joint CSIR, UGC, JRF and NET in Chemical Sciences. Awarded National Postdoctoral Fellowship by SERB, India. Invited as visiting professor by Brescia University, Italy. Awarded a postdoctoral fellowship in Hanyang University under a Brain Korea scheme. On behalf of all the members and the management, we would like to extend our warmest welcome and good wishes. Now, I am hand over the session to Dr. Iseki Karthik sir to present the webinar. Welcome you, sir.
Thank you, madam. Hello, is it audible?
We can hear you, sir.
Yeah. Shall I share my presentation?
Yeah, you can share your presentation and you can continue your talk, sir.
Hello, Segar?
Yes, we can. Yes,
Yeah.
we are able to hear you and we can able to see your screen also.
Yeah,
It's fine.
Thank you for such a warm welcome, such a big introduction. Even I didn't have that type of chronological order introduction. Even I don't have about myself. Thank you, madam. And whatever introduction they gave, principal from Sumangali, she also explained very nicely about sustainability in chemistry. Thank you. Now, though I worked in water electrolyzer and fuel cell, actually in the empowerment opportunity, particularly students who are finishing masters chemistry and engineering in mechanical department and chemical engineering, corrosion science is having huge oil and gas area, downstream, upstream area, everything I will explain in detail following slides. That's what I feel this is a women's college and it would be very appropriate to present this thing. Then with this, I can go to my next slide. Yeah, this is the, sorry. AMPP performance. Actually, previously it was a NACE, National Accreditation of Corrosion Engineering. Now they have converted to the AMP. This AMP, whoever wants after finishing MSc, whoever wants to actually get a corrosion related job, the corrosion inhibitor or material production, they can join in this AMP concern and they can get some certification course. After getting certification course, getting job is very easy. And the training program, they have different kind of training program, cathodic production, specialty coating, and cathodic coating inspectors like that. Once you go through this website, whatever I have in fifth point I have shown, then you can understand AMPP. This is it will be very useful to get job opportunity, particularly empowering yourself. Even whatever you are studying, physical industry, you can directly see how it is useful and how can I even research side as well as commercial industrial aspects also, you can easily get placement everything. Then opportunity like refineries, water-based business like water distribution, power plants are plenty now. And then many levels are there. You can get different levels of certificates. That certification definitely it will help you to get good jobs even not only in India, abroad also. And of course, very limited number of people are having this certification because it is not well aware among the people. If you see that too, female participation is very less in this area. That's what I would like to show this information before going into detail about corrosion science. Then opportunities. What are the opportunities are there? Opportunities means after studying, what are the research area, what are the things you can do it. That is first the inhibitor development. Paint industry like Berger, DuPont, Akzo Nobel, Asian Paints. Those paint industry, they are always searching people who knows inhibitors, how to reduce the corrosion. I will tell in detail what the inhibitor inhibitor will do and how actually you can control the corrosion through inhibitor action. Everything I will explain in later slides. Then next to polymer coating. Polymer coating also the even many paint based suppliers are there like Autotech, General Electrical, Suez. Those companies they are also searching, and when the person is having knowledge in paint and polymer as well as related to corrosion certification, easily get a job in this area. Then cathodic production, particularly India, it is very rare. But when you go to a Gulf country like oil, downstream applications, I will tell what is downstream. Downstream and upstream, two streams are there. One is when you are taking crude oil, but the crude oil when you are cracking from the earth, that is called upstream. See, then after taking crude oil, when you are supplying to outside, wherever refinery and wherever you are supplied, that is called downstream. Only upstream and downstream. Though those stream is having a lot of problem due to corrosion because anyway we are handling with highly inflammable liquids and inflammable gases. If corrosion or something is happen, it is unbearable accident. It may happen. That's what they are very careful about corrosion things, and they will invest so much amount of money. Particularly, the company like Aramco and many Russian companies, they are investing huge amount of money. These areas, both research side and industrial side, opportunities are huge. And specialty coating. Specialty coating means nowadays, see, when we are going ahead of summer and at the same time winter, we need protection from the heat. Actually, whatever heat, suppose in winter season, whatever heat we are generating inside the house, and we need some thermal insulation. Similarly, summertime, we don't want to allow sun heat to enter inside. For that, people are developing different kind of coating, heat resistance coating, and then chemical resistance coating, particularly for when we store the chemicals like acids, base, and that time they need their own coating. In that area also, opportunities too huge. And but these areas, unfortunately, in publication aspects, research aspects, it is not you cannot achieve much. But of course, industrial aspects, commercial aspects, the opportunities are very high. And stress resistance, particularly for hydrogen production. When you produce hydrogen, after producing hydrogen or oxygen, but of course we need to store it. When we want to store, that time what will happen? These gaseous molecule can penetrate easily the material. That time it will generate stress. That stress, how to avoid this stress corrosion? It's a very big problem, world over problem. But still, they are managing it their own protocol and still research that as biodegradable switches. Now people are using it. These type of applications, when we understand the corrosion phenomena, that too in biological medium, biological condition, then the opportunities in medical field is also very high. Of course, as I earlier told, downstream operations like Reliance Industry, petrochemical industry, they have their own corrosion team. Sometimes they are outsourcing their business. Other people will come and they will audit it and they will give the suggestion. Based on that, they are doing it. And these many opportunities are there. It is very unfortunate. People actually only CECRI, you can get some corrosion related PhD. All other organization, you may not get it in India. Well studies, actually, when you want to study corrosion related studies, it is very unfortunate. Other places, it is not available. But through the certification courses, you can easily enter. Then now I would like to start with the 8 types of corrosions. What are the 8 types of corrosions are there? First, actually, it is majorly classified with the 8 types. Before I am going into the types, I would like to mention about the what is corrosion. I can tell. Suppose you have a material. That material we want to use prolonged time. Because of some other external reactions and external influence, the material will undergo degradation. That degradation, because of that degradation, you cannot use it. That degradation, it may come from some chemical reaction, it may come from mechanical disturbance, it may come from some photo reactions, brittleness, everything may happen. These because of these issue, we cannot handle our whatever material we are using it. Then people classified. It's a scientist earlier they classified these corrosion system in eight classification. Already they have done it. That 80 classification, first one is uniform attack. Suppose you have a metal. That metal, when you are keeping into the acidic medium, that time what will happen? Of course, metal will get dissolved. That is called the uniform. Completely it will dissolve. That is the uniform attack or uniform corrosion, they will say. Galvanic corrosion, you may see wherever you go. Suppose in a railway station and bus stand, you have here. I have mentioned some photos are there. My actually galvanic corrosion, nut and bolt is there. Why it is happening means the nut is made up of different metal and the bolt is made up of different metal. That time it has its own electrochemical cell will form. Then what are the metal? It is highly noble, and that metal will accelerate the oxygen reduction reaction. What are the metal? It is least noble, highly noble. Here, based on what I am saying, electrochemical redox potential. Suppose some material, bolt is made up of, we can think bolt is made up of nickel, and nickel enriched metal, and a nut is made up of, let us say, copper. Copper is more noble than nickel. Then what happens? Copper will accelerate the oxygen reduction reaction, and nickel will undergo the leaching process. In this way, wherever you have two metal junctions are there, there galvanic corrosion is happening. That galvanic corrosion we have to avoid it. Otherwise, material will degrade. I will tell how to avoid it that also. Then next, crevice corrosion. Crevice corrosion is suppose you have metal, somewhere else you have some crust and drift, some small crack is there. That places what happens, the edge of the crack, it will be highly polarized. In polarized means the field will be very high, electric field. Because of that polarized nature, the crevice corrosion always it will happen in the, see here, crevice corrosion in this slide I am showing. Wherever some small crack, small disturbance is there on the metal instead of smooth surface, then crevice corrosion definitely will happen. Then intergranular corrosion during the metallurgy process, when they are making metals, that time when they are crystallizing out, when they are crystallizing unevenly, that time what happens, while you are actually melting the metal during the cooling down is the crystallization process. The cooling down, when you are not cooling down properly, that time the whatever metal granule is forming, that won't be evenly, it won't be forming. Because of that thing, every granule is having its own, it will feel the stress. Some granular sizes will be very high, some granular sizes will be very less, and some granular it will form over by other one. Then because of that stress, and it will undergo the corrosion. This is only because of the metallurgical aspect. They are when they make some mistake, of course we will end up with the intergranular corrosion. Selective leaching means suppose you have a alloy, different alloy we are using, and from automobile industry to home appliances. That alloys that alloy contains both, as I earlier told, many metals are there. In that different metals, suppose some metals are having zinc, let us say zinc with the copper. Zinc can easily be leached out. Then slowly zinc is coming out. That is called only particular which is highly non-noble. It will be coming out. That is called selective leaching. Of course, erosion, wherever we are having water is flowing or material is flowing, that time because of the friction, this erosion mainly people are using in automobile industry. The automobile industry, they are making wear resistive material. See, wherever the friction, mechanical energy transformation is there, that time how to control the wear resistance, because you have a piston. Suppose some one wheel to another wheel, you are transferring your mechanical energy. That time what will happen? Because of this erosion and the friction, that material will undergo the erosion. Actually, it will be, because of the friction, it will undergo the some problem and some brittleness it may form. That erosion corrosion also we have to. It has its own mm, process, we can remove it. I tell you. Then stress corrosion, of course, as I earlier told, when the gas or something, when it diffuses to the metal lattice, or that time through that gas molecule, and the whole lattice will feel this strain and stress, then material will undergo that way also corrosion. Also recently, photo corrosion and microbial corrosion also people are studying, where they are using photocatalytic application and photo conversion application. There they are actually studying photo corrosion. Microbial corrosion, of course, wherever we are using our even public toilet and medical industry, there of course microbial corrosion is prone to happen. That also there recently they are people have started to study. Then this is actually basic job. Before going into the deep corrosion, I would like to mention the Latimer series. Suppose based on this, my left side I have had a Latimer series. In that Latimer series, if you see, lithium is having very high negative potential, and fluorine is having very high positive potential. These are of the reduction series. Suppose some material is having high positive potential, it means that material is highly noble. Earlier I used two words, one is noble and non-noble. Noble means nothing but the material is having high positive potential. Suppose gold, let us say gold is having positive potential of 1.498. See, because of this reason, then when whatever the material is having high positive reduction potential, that material cannot be corroded easily. Because of this reason only, in electronic industry, whenever you open the chip, pen drive, or even your laptop, they have their own gold coating. Of course, inside they have copper connection is there, but to increase the lifetime of that electronic devices, they have a gold coating. They used to have it because of this high reduction potential. But you see, yearly first when they started understanding corrosion, they are trying to understand corrosion with this Latimer series. But unfortunately, this Latimer series, it is not helpful to understand beyond particular level. Why I am saying, in this Latimer series, you see aluminum. Aluminum is having reduction potential minus 1.662 volt. It means aluminum can be undergoing corrosion very easily than uh, other material like iron, zinc, like that. But in day-to-day life, in real field, aluminum is not undergoing corrosion as easy as iron or zinc. The reason is aluminum immediately it will form the aluminum oxide layer. Here I have mentioned. When once you take the aluminum paper, wherever you are buying from the commercially from market and everything, but initially it may be very clean. Actually, what can you, very whitish color. When you look at it, very, very deeply, but thin whitish, very pale kind of whitish layer coating will be forming. Because of this coating, that coating is nothing but aluminum oxide layer. Because of this coating, any molecule can penetrate to any molecule means particularly oxygen. Oxygen cannot penetrate through the this aluminum oxide layer. Aluminum oxide layer is highly inert, and aluminum oxide layer won't conduct the electricity. Aluminum oxide, because of this reason, though this Latimer series sometimes it is not useful. Then people have moved to the pore bias diagram. Okay, if Latimer series is not using, then they have constructed their own diagram. Pore bias diagram is nothing but every metal they are having, we have different metals and different elements are there. They are studying all the periodic elements. They are with the different pH and different potential. They have studied what is the phase is forming. Let us say here iron pH here we can consider pH 2 and up to minus 1.6 to minus 0.8. Iron will be iron only, all pH almost up to minus 0.8. But when they go to the beyond minus 0.8, iron will become one side. Actually, if you go to the higher pH side, iron will become iron hydroxide, and that left side iron will become iron 2 plus. Because if you have pH lower pH, acidic pH, of course iron will be leached out to form corresponding salt, iron chloride or iron sulfate, whatever acid you are using. Then similarly, when you go beyond the potential, then Fe3 plus will form. But this is highly useful to understand the thermodynamic of the present condition. But we need to know kinetics, how fast corrosion is happening. See, of course, after corrosion is happening, this material will be converted to this type of form. We can understand. But I have a material. That material, if I know the rate of the corrosion, then only I can understand how long this material will come. That information, unfortunately, we cannot get from the 4-batch diagram. Because of this problem, people have gone to the Evans diagram, next level diagram they have got. Evans diagram based on the every material potential, every material electrochemical potential, and they have constructed theoretically, they have constructed based on the current density. They measured actually if the material, suppose Fe2 plus material, the current in first that equilibrium, if the equilibrium gives this much current density, then they have extrapolated. During the extrapolation, they found out the E corrosion, E car, I car, everything they found out. Then based on that, they have calculated the corrosion rate. That we will see in the next slide. Then this is theoretical picture. Theoretically they plotted, and experimentally this same Evans diagram we can get through Tafel plot. That also we can see. Yeah, these are all the basic method. Okay, that is just the introduction I have given. But basically, when you have some material, how do you measure the corrosion? Now, in general, first people will measure through weight loss method. Suppose let us say you have iron rod. People will ask you, go measure the corrosion. Then what you have to do? So measure the corrosion in particular medium. Okay, 3 molar NaCl or 6 molar NaCl. You have to keep into that iron rod sometime. Then after maybe 1 week or 2 weeks. After that, whatever the corrosion product is forming, you have to remove it. Before keeping into that NaCl medium, you have to measure the weight. After keeping into that NaCl medium and removing the corrosion layer, you have to measure the weight. How much weight loss is there? Based on that, you can measure it. But the weight loss method, though, okay, I will tell you later. I will come to that. But the weight loss method, I will finish it. This weight loss method is time-consuming process. When it takes lot of time because you need to wait up to some layer is forming. Then, but it is a perfect method. You can believe the result. But the analysis, when you do analysis, has to be performed properly. Means you should not remove the layer of the metal surface. When you remove the layer of the metal surface, what happens? The real corrosion rate, we will end up with the wrong result. And then high rate, suppose corrosion is happening with high rate, then only you can measure. At least it will take its own time, 2-3 months. If it is high rate, at least after 1 or 2 months, you can measure the corrosion rate. Once you know the weight loss, here, this is the equation that is called mils per year. 1 mil approximately it is equal to 0.0254 millimeter. That much. Mils per year means per year how many mils you are losing due to corrosion. That is, when you have weight loss, W is how much weight loss you are seeing. 534 divided by D is density of the sample, whatever sample you are taking. Area, how much area you are using it. That one. T is period of exposure, how long you are keeping your sample. With this, you can find out the rate of the corrosion. The only problem is where you are using corrosion inhibitor. Let us say, suppose you in normal the corrosion rate is very high. When you add some inhibitor like amine-based organic compounds or amino acids or sulfur-based compounds, that time these compounds it will form the protective layer on the surface, metal surface. This protective layer it won't allow the corrosion process, and slowly it will slow down the corrosion rate. When it slow down the corrosion rate, you have to wait at least some small layer. It will form after 2 months, after 3 months, even sometimes 6 months. Then because of these reasons, and when your inhibitor is working very well to prevent the corrosion, that time you need to wait so long time. Because of this problem, people have moved to the linear polarization method. This is completely electrochemical method. You have a coupon. That coupon, when you keep it to the coupon, connect into the experimental setup. I will tell you the later because that is separate. We need to discuss it separately how the experimental setup is. It has its own counter electrode, working electrode, reference electrode, everything. When you keep the coupon, that time when you slightly polarize your electrode slightly anodically or cathodically, minus means minus from minus 2.9 minus 737 millivolt to plus minus 707 millivolt they have given with respect to SCE. When you polarize it, how much current is flowing in that system? That is called a linear polarization method, linear polarization resistance method. From the slope of this graph, you can find out the resistance polarization, RP you can find out. When you know the RP, this RP will tell about the rate of the corrosion current. One RP is corrosion resistant. When you inverse it, that is corrosion current. Then once you know the RP, Then after that, you have to do the TAFL method. You have to run the TAFL analysis. When you do TAFL analysis with the different, see here I have mentioned in the stainless steel, different 0.05 molar NaOH to 0.5 molar NaOH. When I run the corrosion, of course 0.5 molar is having more compared to 0.05 molar NaOH, 0.5 molar is having higher corrosion because because when we increase the amount of basicity, then the corrosion rate will increase it. That you can see from the here you have two types of parameters. One is corrosion potential, another one is corrosion current. How do you calculate here in my right hand side? When whatever TAFL plot is there, TAFL plot, when you in the tangent line of that TAFL plot, when you take it, where it is merging together, there if you see in the potential axis, that is corrosion potential. In the current axis, that is called corrosion current. TAFL plot, you can plot either x-axis potential and y-axis current, or reverse also. That's what both I have shown. When you see in the literature, they will show like potential in the y-axis and current in the x-axis. Mostly current it should be in logarithmic scale. Then only you can find out the corrosion rate everything. Well, once you know the here corrosion potential to tell about the thermodynamic of the your corrosion process. If the corrosion potential is highly, when it is moving towards the positive side, see here in my left side graph, 0.05 molar NaOH, that is slightly positive than 0.5 molar NaOH. Approximately, it is more than minus 1430, 50 like that, 0.05. But when you go to the 0.5 molar NaOH, it is nearly something 1490. Then whenever corrosion rate, whenever you are suppressing the corrosion, that time slowly it will move to the positive side. Because whenever, as I earlier told, the redox potential should be positive, like that it will move. How long, how much it is when you are moving, that much it is good. Because these changes you can, when you add inhibitor, when you choose appropriate coating, you can achieve it. But this is only thermodynamic thing. Kinetic parameter, when you come to know the corrosion current is nothing but ICAR. When you know the ICAR, I told two tangent line. The two tangent line is having its own slope. Anodic tangent line means wherever the positive potential is, positively was minus 0.8 to minus 0.2. That area is positive area. Minus 0.8 to minus 1.2. This is negative side area, cathodic area. Positive side we used to call anodic area, negative side is cathodic area. When you take slope of these two things, then if you put in that equation, already we know the corrosion resistance. When you actually use this about the test, equation number 2, constant ICAR, then you can calculate the ICAR calculation. Once you know the ICAR, this is, I tell you why. This is using Stern-Gary corrosion rate calculation. This, once you know the ICAR, you will come to know the ICAR. Here they have measured the 0.1 microampere per centimeter square. Then based on that ICAR, once you know the material equivalent weight and the density of your material, then you can you can easily calculate the mils per year. How much mils per year? How many mils it is leaching out? Based on this evaluation only, people are checking. Yeah, now I have to show the inhibitor. Yeah, people are checking inhibitor. You suppose being a chemist, when you get a position in a research institute or some company, they will ask you to prepare different kind of inhibitors. Inhibitor means which can, mostly it is made up of amine or phosphorus, organophosphorus, or even glucose, actually polysaccharide kind of material. That material will inhibit it will form the layer, its own layer. After making inhibitor, whatever earlier studies I told, you have to perform it. Okay, then okay, my inhibitor is working like that, and this can be a very good inhibitor. Then people will supply to the companies. Then companies will take, of course, they will use for their own applications like paint industry and particularly oil companies. They will use it. This is one of the main things. Then next is some people, some research institute and company, they will ask you to prepare polymer coating, different like now people are using tile-based polymer. After coating polymer, they will go for this analysis. Okay, these are the analysis. Okay, here the question is, I told here we can take the tangent line. Exactly where we have to take the tangent line, because it is like lean, it is the curvy nature. Whenever you see the curve is having infinity tangent because curve doesn't have a single slope. Curve is having a function of slopes. Then the thing is, suppose when you know actually in general people will take 120 millivolt from the your potential. That is the TAFL region. Why we are taking 120 millivolt? That region is called we used to call that is high field region. I hope you might have studied, most of the people, mostly chemistry background people might have studied the Butler equation. If you have any doubt, I will explain after this presentation. This is the Butler equation. I is equal to I0 exponential 1 minus eta, 1 minus alpha eta divided by RT minus exponential alpha eta divided by RT. This is a very good equation. It can relate the most of the interfacial current potential relationship. When you in this equation, when you put the 120 millivolts, suppose 1 minus alpha eta divided by RT is, if you consider that is anodic part, of course alpha eta divided by RT is a cathodic part. If you go to the 120 millivolt agate of anodic side, then that time you can completely nullify the cathodic part. When you completely nullify the cathodic part, then only you can end up with the TAFL equations like eta, mod of eta. Why I am putting mod means here actually that sign only it signifies the cathode or anode. That's what normally sign is not a matter. That's a mod of eta is equal to a plus beta into L and G. This is the here we are plotting actually L and J versus eta. Eta is nothing but potential. L and J is a logarithm of current. Then this is the important equations for TAFL approximation. Then okay, this is okay. Up to this, these are the classical studies. Here, I would like to introduce some Fourier transform analysis. Suppose in the real field, whatever analysis you are doing, most of the analysis is a time domain analysis. So either time domain analysis or otherwise spatial domain analysis. Any experiment, any scientific experiment, you can perform with respect to time, what is happening, or otherwise with respect to space. Suppose you have suppose when you want to measure something, okay, x coordinate or y coordinate, I am measuring this thing. You can say, suppose where microscopy or electron microscopy, that is called or spatial resolutions analysis. So, or otherwise, when you take any spectroscopic analysis, any corrosion analysis, any kinetic analysis, you can measure only with respect to time. Whenever you are measuring with respect to time, that time, of course, we will end up with the, normally in real world actually signals are very noisy. That time what we have to do in general, this Fourier transform they will do. When here suppose you are getting signal with respect to time, you have two signals are there. Just assume it. You are getting signal like this. Then when you do the Fourier transform analysis, you will end up with these two things. Why I am telling here, corrosion also you can study like this. I will show in the next slide. Based on this approach, when you remove the signal, people are utilizing in NMR spectroscopy, IR spectroscopy, and Raman spectroscopy, and different kind of even music analysis, electroencephalogram, electrocardiography, medical analysis, even from satellite, they are trying to measure the sea level. Because sea level, wave level, how much it is increasing, how much it is decreasing. With respect to time only, they are having data. After getting data, they are analyzing the signal. When they do Fourier transform, then only they can get it. Actually, time with respect to time and amplitude, you will get the signal. When you do FFT, of course, you will get the frequency.
For the researchers. So that is a continuous desalination in single device from seawater to freshwater level. Whether it is possible, this question is arised for many researchers. So I want to tell there are many groups who have been working in the electrochemical desalination. They remove from 35% NaCl to 5%. I think it's very small. I can so yeah. Here you can see. For example, I will explain this technique. Here we have kept two electrodes. This Professor Fumington is my professor, my supervisor in South China Normal University. I have joined to this group. Then I have read his paper, what he was doing. I need to know what he was doing. Then one day I can implement my work, right? So I read his paper. He kept two electrodes in the device, a single device, he kept a negative and a positive electrode at the both sides, and he placed two membranes, that is cationic membrane and the anionic membrane at the middle portion, and he supplied salt water to from one end to another end. At the same time, these two compartments contains redox species. Redox species is nothing but a chemical compound which a capability have a capability to do oxidation reaction as well as reduction reaction. That is called redox species in general. These redox species have been supplied in through this channel. It is recirculated. Okay, for example, the first when we apply the electricity, when the oxidation reaction takes place at the negative at the positive electrode, it loses the electron and it takes up the sodium ion through cationic exchange membrane. Whereas the same opposite reaction takes place at the another electrode. So this reaction happens. You can see at the right side the continuous salt removal from at least from 7,000 ppm to nearly 5 ppm like that. Sorry, 10 ppm like that. So now with the researchers proved that we can do continuous desalination from high level of salinity to low level. So these are the proofs have been done by our group. Okay, now I want to speak about what is the need to go for photo electrochemical desalination. Before that, I want to show what is the photo electrochemical. The combination of chemical energy and chemical energy. Sorry, yeah, the process of the chemical energy and electrical energy is nothing but the batteries. That is called electrochemical. For example, the batteries, which battery operates through electrochemistry. And another is the combination of chemical energy and solar energy is nothing but photosynthesis. And the combination of solar energy and electrical energy is the photoelectric devices. Recently, they were using for sensor applications like that, photosensors like that. What will happen if you combine the three things? That is solar energy, electrical, and chemical energy. Either it is coming using a solar energy, the electricity will come out, or chemical energy will come out. When we combine these three energies, we can get a photo electrochemical process. That is, either we can use for energy conversion or energy storage. Okay, this so then we were when we discussing with my professor, we plan to do solar driven desalination because for electrochemical however, electrochemical desalination is a very new hot topic. It needs some electrical energy, right? As I said in the first slide, we need to save electricity. For that, when this device is done in our lab level, when we going for commercialization, we need a lot of energy, electrical energy, to operate the system. So myself and my professor Fewington, when we discussed together, we have planned to do photo electrochemical desalination. What we have done means, in the previous slide, we have a negative electrode and photoelectrode. And we plan to remove a negative electrode and replace it with photoanode. So what happened means, in the photoanode, it contains a photoactive material. This is the photoactive material. Sorry, LEG4 dye. This dye is more responsible for solar energy. When we illuminate sunlight, this kind of molecule will exit the electron. When it exits the electron, this electron will be captured by the conductive electrode, and it goes to the external. Through the external, the electron will be received by the cathode to initiate the reaction. So it completes the cycling of the electron. Whereas this redox species will give electron to the excited molecule. This compound, the compound, the tempo is not. This is the redox species. It is recirculating in the between photoanode and cathode. So this will take the electron and give electron to the LEG4 dye. In the right side, you can see, in this case, we have received only 0.1 milliamps. And In the next case, one of my student, PhD student, Mengjun, she replaced the photo cathode. In the here also they cannot achieve the current density is very low, 0.2 milliamps. And finally, I make integrated device, integrated device, and increase the current density from
Due to signal problem, speaker has left. He is trying to connect it again. Be patient and be on the online.
output. That is, this a single device can give electricity as well as the desalination. And also, in this work, we have achieved, I think we have achieved 500 ppm, nearly freshwater level. But another work we have done, and it is published in small, I have not shown in the slide. Here we have achieved 5 ppm by just doing some engineering work in the previous device. In this device, I have done some engineering work and improved the device performance. Ultra high quality freshwater, that is 5 ppm. Just imagine, we have decreased that 500 ppm to 5 ppm level. So, what I'm coming to say means, this kind of technology we can use our renewable energy for different kind of purposes. In my work, I am focusing only on the desalination, because in future we are going to face the energy crisis and water scarcity. So everything will become a complicated problem for the human being, right? So hence I am focusing on the photo desalination. That's all. My presentation is completed. I want to give acknowledgement to the ICWS organizer and members, and my professor Fuming Chen. And these are the professors: David Waite from Australia, Volker Presser from Germany, Dr. Ganguly Babu and Pulikil M. Ajay from USA. They are very good supporters for my work. I have shared my work to them, and they are the one of the co-authors in my publications. They have encouraged my work, so I am giving my acknowledgement to my professor, and obviously I am giving my acknowledgement to my spouse and my family and friends. Thank you, my dear friends. So here, what I'm coming to say, the Albert Einstein, he said, imagination is more important than knowledge. Of course, now students are gaining more knowledge in universities. Once you come out from the university, you just want to go for imagination. How you can implement the knowledge into outsources, and you need to. We are the one need to save our earth, right? So just imagine what you have to do in the future. Thank you.
Thank you very much for your presentation, sir. It was very nice. So I request the participants to clarify the doubts. Now the session is open for interaction. There is a question in chat box from Usha. She said, "Sir, normally the electron excitation is from HOMO to LUMO, but you said it in another way. Can you
Okay.
clarify?"
Sorry. Sorry, it's from
So
Lumo to LUMO.
you can comment on that question, sir. Maybe it will be more clar.
Okay. Any more questions?
So I request participants to interact to get clarification.
No problem. If they hesitate to ask questions, I will ping my email ID in the chat box so they can communicate with me, whatever it is.
So our delegate has shared his mail in chat box. Those who want to ask a question, you can mail him. So now if there are no more questions, I can hand over the session to MC students
I think
to further.
someone is coming, has raised hand.
So K Nagaraj, you can ask now.
Uh, Sorry, can you hear me, sir? Yes, I'm Navraj. Sir. Can you hear me, sir? Can I ask one question?
Yeah. Yes, sure.
So,
Hello.
my doubt is the same.
Can you
Now,
type your question in the chat box so that I can answer you?
Nagraj, you are not audible clearly, so you can type your question in the chat box. If you are not able to make it clear audio.
I think
Mr. Nagraj?
he can type the question in the chat box.
Okay, sir. Sure, sir. I will, sir. Thank you, sir.
Rishikant, you can ask the questions now.
Yes, sir, I have a doubt, sir.
Yeah, please.
Dear Karthi, you have shown one device based on FTO. Can you please share the slide?
Sorry, sorry,
Rishikant, your background is very much noisy. Can you make it clear? Your voice is not audible clearly. Your background noise is predominating. Rishikant, you can ask the question. Your background is very noisy. You can clear that and you can ask it back.
Yes, sir, yes, sir. Dear Karthi, you have shown one device. Can you please share the slide?
Shekhar,
Rishi, otherwise you can type the question on chat box. Your voice is not audible clearly.
ask them to put their queries in the chat box, bro.
So participants, if you are not audible clearly, you can left your question on chat box. On behalf of you, I can ask the speaker to make it more clarified regarding that. So here is a question from Rishi. So you have shown the device structure based on FTO. Please share the slide. I have few queries on that. Sir, Karthik sir.
Oh, I got it. You have shown one device structure based on FTO. Please share that slide. I have a few queries. Okay, I will share now. Let me share. This one, right?
Yes, sir, this one, sir.
What's your doubt? So, what do you want to know from this device? Hello, Miss Rishi?
Sir, meanwhile, you can answer another question from K. Nagraj. He is asking,
Desalination technology applicable to remove heavy metals like arsenic from water. Yeah, in desalination also the same process have been doing for the removal of ions like arsenic from water. But that kind of things we cannot merge with the desalination part because we are only focusing on the brackish water or the river water like that. If you want, if you want to go for removal of heavy metals from water. For that, we need to go for that is like a complicated issues. For example, what I did in my work, I have coupled solar cell with redox flow desalinator. The same thing we can couple the removal of heavy metals from water with the desalination process. But we can do it. It is very possible, but we need to think how the process can be done. Because for removal of heavy metals, we need to uh, decorate a suitable electrode material. At the same time, that electrode material should remove the heavy metals. So both dual process should be done by the same electrode. So that it is possible, but we can think. And another one, can we use microorganisms which can survive in high saline condition for initial treatment? Yes, of course, we can do before we are supply the brackish water or sea water to our device. We can give some pre-treatment to destroy the degrade the microorganisms either by photo method or electrochemical method or some other method technologies. We can remove the microorganisms and finally we can supply to the electrochemical device.
Thank you,
With,
sir. There is one more question from Usha. Can we
yeah,
use
just now,
microorganism which...
yeah, just now I answered for that question also, bro.
Okay, thank you very much, sir.
Yeah,
So
that is
it's
called
a really very interesting topic.
the question raised by Usha. She can read some papers like microbial desalination method. There are in one of the paper is very good work they have done photo microbial desalination. For example, they have used gamma based Fe2O3 as a light absorber, which it oxidize microorganisms, and also simultaneously they have removed ions from the desalination plant. I can share the paper laterly if you connect my Gmail. I can share this paper. It's very good work.
Okay, sir. It's really very interesting talk about all kind of renewable energy and how it can be transferred to technology for desalination. So, which is very important to humankind for the survival. Uh, it was very nice, and I feel very thankful for giving this lecture in this event, sir. So if there are more questions, you can connect him through Gmail, which he has shared in the chat box.
Yeah.
Thank you very much, sir.
Thank you, Sega.
May I now invite Dr. R. Dinesh Kumar, Assistant Professor, Department of Physics, to give valedictory address regarding the webinar.
Good afternoon, respected resource persons, participants, Reverend Mother C. Noel Rani, FSAG Secretary, Reverend Dr. E. Lita Sumangali, FSAG Principal, Reverend Sister A. John Diana, FSAG Vice Principal, Dr. S. Shagar, Assistant Professor, Department of Chemistry, convener of this international webinar. Ms. C. Anjali, Assistant Professor and Head, Department of Chemistry, also the coordinator of this international webinar, organizing secretary, committee members, teaching and non-teaching staffs. I am honored to address this gathering for today's international webinar on chemical science for sustainability. On behalf of Gonzaga family, I would like to express my sincere gratitude to our delegates and participants for their presence with their busy schedule. I consider it a privilege to deliver the valedictory address at this international webinar on chemical science for sustainability. Session 1 proceeded by the eminent speaker, Dr. Yasaki Karthik, research scientist from Research Institute for Sustainable Energy, RISE. Kolkata, had shared about the basics and importance of corrosion science. We should also feel very proud that we had Dr. Esaki Karthik as an eminent speaker who had completed his doctorate from CSIR Sikri, Karaikudi Institute of National Importance in India. Session 2 proceeded by the eminent speaker Dr. R. Karthik, research professor, South China, Normal University, China. He has shared about photo desalination, a new era of the desalination technologies. I can confidently say that the aim of this international webinar on chemical science for sustainability to motivate and to enrich the participants in the field of chemical science and sustainability has been achieved. I am sure that the webinar has made a major contribution to enhance the understanding related to chemical science and sustainability among the participants. I am also glad to be acquainted with the participants and the delegates from India and China. I do hope that they have also enjoyed the webinar. On behalf of Gonzaga College of Arts and Science, we also request the delegates to give continuous support, help in developing R&D cell of our college and for conducting more scientific programs in future. I once again thank each and everyone who made this webinar successful and for giving me the opportunity to share my view on this webinar. Thank you.
Thank you, sir. Now, I invite Ms. P. Jayashree, Assistant Professor, Department of Chemistry, to deliver the vote of thanks. Welcome you, ma'am.
Good afternoon to everyone. It's my pleasure to propose vote of thanks on this wonderful moment. First, I thank Almighty God who pours His blessing upon us throughout the day. Our most valuable dignitaries, respected faculty members, and my dear students, I am happy to honor few words of gratitude on this wonderful day. I deem it's a pleasure to thank our secretary, Reverend Mother C. Noel Rani, FSAG, who is the backbone of the college. She always shows her kindness with every noble cause of activity for the welfare of the student and for our department. Thank you, Mother. I feel proud to convey my thanks to our beloved principal, Reverend Dr. E. Glita Sumangali, FSAG.